Welcome to this video on distributions of the sample proportion, part 4. Let's begin. By the end of this video, you should be able to determine whether a word problem meets all requirements of the sampling distribution and use the sampling distribution of a sample proportion, p hat, to find the probability of events. Let's read this example. It says, suppose a manufacturer is testing for quality control. Past data suggests that only 2% of the widgets are defective. The company makes 1,000 widgets each month. In a given month, they inspect 200 of these widgets. Find the probability that more than 3% of the sample will be defective. So the first thing we have to do is start checking all of the requirements. First of all, there have to be two possible outcomes, which we define as success and failure. So success will be the widget was defective and the failure is not defective. Again, I will remind you, in real life, success would be that it's not defective, right? But again, in statistics, success is the presence of an attribute, which is that it's defective. Failure is the absence of that. It doesn't have the same connotation as it does in everyday life, that success has to be something desirable or something you want. So first of all, the trials have to be independent, and the way we achieve this is to say that our sample is less than or equal to 5% of the total population. So our total population we are given is 1,000. They make 1,000 widgets a month, and our sample size is 200. Well, what is 5% of 1,000? Well, 5% of 1,000 is 50. So 200 is too big. 200 is more than 5% of our population. So if we did that, we could not treat the trials as independent. So that means that our requirements are not met. And at this point, we just have to stop. We can't continue with this test. So, not to fear, because you were probably hoping for an actual problem. So I have modified this slightly so that all of our requirements are met. So it says, again, manufacturer is testing for quality control. Past data suggests that only 2% of the widgets are defective, same as last time. This time, the company makes 1 million widgets each month, and they inspect 2,000 of them in a month. Find the probability that more than 2.5% of the sample will be defective. So we've already established that success is a device is defective and failure is that it's not defective. The trials have to be independent. This time we have a million. 1 million is our population size, 2,000 is our sample size. As you can see, 5% of a million is 50,000. 2,000 is clearly less than that, so that requirement has been met. The probability of success, P, has to be constant, and it is. The probability that a widget is defective is 2%. There have to be a fixed number of trials, which is, again, our sample size, which is 2,000. The shape of the sampling distribution can be considered normal, assuming that there's at least 10 successes and 10 failures. So we use N, P, and Q to calculate that. As you can see, the number of successes, which is the total number of, or the sample size rather, times the probability that a device is defective. So 2,000 times 0.02 is 40. The number of failures, that is failures meaning that it's not defective, is 1960. So both of those are above 10, which is all we really care about, so we can proceed with this sampling distribution. So in order to answer this question, we have to first find the population proportion. Again, I encourage you to pause this video and get an answer before I give it to you. So our population proportion, as you can see, is 2%. Then we need our sample size. The sample size is 2,000. Then we need our sample proportion, p hat, and that is 2.5. Now, the thing that sometimes students get confused between, and very reasonably so, is how do I know which of these 2% is the sample proportion, and how do I know which one is the population, right? Well, the big key here, as you can see, is it says find the probability that more than 2.5% of the sample. It says it right here. So if this is the sample proportion, then by default, the other number must be the population proportion. So we're going to use all of this information to then calculate the standard deviation. So let's go ahead and do that. So again, here's just the summary of the information that we have. Remember, we're treating our population proportion, which is 2%, as the mean. That's going to be the center of this distribution. And so then we use our these values to calculate our standard deviation, which we've done here. And as you can see, you plug that into a calculator and you get about 0.0031. Okay, so now, as I said in past videos, you can use technology or by hand. And either way, I think the important thing is that you are looking at a graph, maybe even sketching it on your paper to visualize what we're really doing. Because the danger is that with either technology or by hand calculations, you just get in a rut and you plug and chug and you don't even pause and think about, hey, what am I doing? What am I really generating here by answering this question? So recall, if you are going to use technology, then you have to use the normal calculator. And hopefully this gives you a little bit of pause because you look at the screen and all of a sudden it's asking for mean and standard deviation. And we're not working with quantitative data, so how on earth can we have a mean and a standard deviation? What on earth are we going to do? So that's why in this particular instance, I feel like the technology makes you think a little bit harder and a little bit more about what we're really doing and what we're trying to achieve. So recall that, again, we are treating our population proportion as the mean. So that's what's going to go in the space that says mean. We already calculated our standard deviation as the square root of PQ over N. And then remember, our random variable is our sample proportion. And again, the keywords in our particular case is more than, so we're going to select the greater than or equal to symbol, or above if it's our guru. So if we're using technology, we're going to type in something maybe that looks something like this. And when we do that, then we should get a nice, beautiful graph. And again, if you're doing this by hand, you can absolutely produce this manually, right? You can stick the population proportion here in the middle, and then you just add the standard deviation to generate the values of your other tick marks. So again, you can do this with technology for sure, but the visualization is so valuable and important because it helps you to understand what we're really doing. So we can see as a result that the probability that a sample of 2,000 randomly selected widgets results in more than 2.5% of defective widgets, there's about a 5.3% chance of that happening. So now that you've watched this video, you should be able to determine whether a word problem meets all the requirements of a sampling distribution, and you should be able to use that sampling distribution of a sample proportion, p hat, to find the probability of an event.